Okay, so good afternoon, everyone. Thank you for joining us today. That's the last seminar of the semester. And I'm very excited to introduce our distinguished speaker today, who came a long way from Asia. You know, he took like 30+ hours of flight. We got here yesterday, and then getting ready for his exciting talk. And it's Professor Vincent WOON. I really recognize Professor WOON as really a rising star or leading expert in the domain of energy and sustainability systems. I get to know about his work by reading his paper actually. A couple years ago, his team published a very nice paper in Science, which is an academic journal for science. And in particular, it's not only published in the Science, but also selected as the cover art of that particular feature of Science magazine. So publishing Science is not easy. And among those dozens of papers in Science of the issue, his paper was selected as cover art feature. So that's really a nice recognition of his work. And of course, he has received many awards, being recognized globally for many efforts and contributions made. And right now, he was previously in Xiamen University in Malaysia as a Malaysian by himself, but now he's working, I think, Hong Kong University of Science and Technology in Guangzhou as well. So please join me to give him a very warm welcome and thank him for joining us today.
Thank you. All right, so thank you so much, Prof. Yu, for your kind introductions, as well as for your invitations to this seminar as well. So once again, everyone, my name is Vincent WOON. All right, it's my pleasure to be here to give you a talk regarding for my research. So today my sharing will be mainly on solid waste emissions and understanding well how does it connect to the global climate goals as well. So before I dive in detail to talk about my research, I also would like to take this opportunity to introduce about my country, all right, and together who am I, and also about my current affiliation as well. So just for information, I come from Malaysia, all right. Malaysia is a very small country located in Southeast Asia. So if you try to zoom in, we are kind of like having some neighboring countries like Singapore, Brunei, together with Thailand as well, all right. The total population is not so huge. I would say it's about 34 millions. Even if you talk about New York City, it's almost like 8 millions. All right, so it's just like 4.5 times as compared to the New York City. I myself coming from the capital cities of Malaysia, which is Kuala Lumpur. All right, so that actually the first two photos shows you our capital cities, the landmark. One is the Petronas Twin Tower. And this is the latest developed building, we call it as Merdeka 118, kind of our second tallest building in the world right at this moment. Malaysia, not just to talk about the city size, we have a lot of nature as well, all right? So you can see some of the mountains and as well as some of the beaches, a beautiful one, all right? We are a tropical country, so we have a lot of tropical fruits. I'm not sure whether you have tried this before, all right? It's what we call as durian, all right? Pretty smelly, all right? Some people really enjoy it, but some people might find it a little bit annoying, I would say that, all right, for this kind of fruit. We also have like a rich diversity in terms of our country. We come with different races, all right? So because of this, we have a lot of foods over there, all right? So once again, if you haven't visited Malaysia before, please welcome to join, to come to Malaysia and visit my country, all right. That's all about my country, and I also would like to take this chance to talk a little bit about myself. So my research are mainly focusing on sustainable process and system analytical approach, mainly to formulate sustainable policy framework. So I take climate change as the main core in my study. But as you know that climate change is always a very complex issue. You are not just like looking into the environmental impact, you have to also understand well how the interplay between the economic together with the social perspective as well. So I'm trying to integrate with different system analytical and as well as the sustainable processes. Right at this moment, integrating with the AI model together with spatial temporal analysis as well, and looking into like different sectors, mainly on solid waste, wastewater, building, energy, transportation, and even agricultural. But most importantly, it's about the implication of the study is to formulate sustainable policy, either from a global perspective like Paris Agreement, net zero emissions, circularity index, or even up until SDG goals, or even from a national perspective like NDC, and lastly to, let's say, a corporate perspective like at this moment we keep looking on the ESG, all right? So before joining academic career, I have a few years experience working on different companies as well, under strategic consulting in Accenture, and also working in township development for almost like 3 years in Malaysia and also in Indonesia. All right. And as introduced by Prof. Yu, right now I'm actually just joined for Hong Kong University of Science and Technology based in Guangzhou. I joined almost like 3 months actually, all right. So I think this is a very good opportunity for me to showcase this new campus to you. This campus actually just established in the year of 2022, so it's a pretty new campus. But if you talk about Hong Kong University of Science and Technology, it's also a very new university. We established in the year of 1991, which is like almost, I would say, 30 years old. All right. So where actually like this Hong Kong University Guangzhou located, it's actually in the heart of Greater Bay Area. So Greater Bay Area is an area in between the Guangzhou area together with Macau and even together with the Hong Kong region. All right. So here you can see how the connectivity between Hong Kong University Guangzhou together with Hong Kong University, you can easily access through the high-speed railway or even to the airport. It's like within an hour distance, all right, in between the Hong Kong University Guangzhou and Hong Kong University. In terms of ranking, we for the QS World University ranking, we rank number 47. And in terms of times higher University Asia ranking, we are 12 in Asia. And also, as I said, we are pretty young university. Right at this moment, we rank at world number 3, and even Hong Kong's number 1 in terms of the ranking for our university. This is like kind of a layout for our new campus. It's not that big as compared to Cornell, I would say that, all right. But it's pretty compact, and we also try to make it as a smart campus as well. So inside this new campus, you can see a lot of smart facilities, all right, and all things like real-time monitoring for your electricity, your water consumption, even all these real-time figures, all right, that you can find out. One innovation about this new campus is that there's no schools, there's no department at all. For this new campus, we are trying to have a new innovative academic structure, which we call it as hubs and trusts. So the idea why we want to focus on this hub and trust is that because we want to foster interdisciplinary research. As we know that right at this moment, if you talk about all these global challenges, you are not just rely on one single knowledge to tackle with all these global challenges. You need to integrate with like different skills, different knowledge in order to overcome it. So this is how we set our like so-called schools. We just only have 4 hubs: function hub, information hub, system hub, and together with society hub. And as I say, we do not have any departments, so all the departments actually we call it as trust, all right? And I myself actually work under this society hub, under the carbon neutrality and climate change trust. So just a little bit ideas about the bird eye view of our university. You can see it's pretty compact. This is the whole academic buildings. The designs of our buildings also have received some of the architectural awards. And this is like the whole buildings that you can see, the main campus. Yeah, so a lot more like photos, all right, for sharing, all right. So once again, feel free, all right, to come to visit this new campus, all right. So that's all about myself, I would say, and also my affiliation. So back to the topic that I would like to share with you today. This is the table of content. I will give you an overview about the research background, mainly to talk about the interconnection between the greenhouse gas emissions together with the Paris Agreement and also the Global Methane Pledge. I will share with you one of my publication, which is the science publications. So over here you can see the research methodology, just an overview about the research methodology, and some of the result and discussion as well. So if time's allow, I will also make some summary to talk a little bit about my other publications that relate to the solid waste emission. So first of all, the research background. If you look into the global pictures of municipal solid waste, when we talk about municipal solid waste, it's the domestic household waste that you generate every day, all right? The global municipal solid waste generation right at this moment, it has already reached like 2.24 billion tons back to the years of 2020. And we know that because of the growing populations, because of the GDP growing as well, that could definitely more and ever increasing municipal solid waste. and expected to like up until 1.7 times as compared to 2020 in the year of 2050. But I would like to draw your attention to the developing countries. You can see that the growth rate actually is much higher than the world's average. And it actually makes sense because when you talk about the growing population in developing countries, it's actually much faster, all right, compared to the developed country. And one thing that I would like to emphasize is about the way how we treat and also to dispose of our municipal solid waste. So according to the World Bank report at this moment, if you look into the different methodologies to treat and also to dispose of the municipal solid waste based on the different income levels, for high income level countries, you can see a diversity in terms of the facilities. That could be ranging from, let's say, landfill to composting to incineration and even to recycling. But if you focus on all those lower middle or even the low income country, it's pretty sad to say that at this moment you can see that mostly are dominated by the open dumping. So open dumping is kind of like open landfill. And what's wrong with this open landfill? We know that open landfill is always unsustainable. It will cause a lot of problems, not just to the environment, but also to our human health. Like for example, if you look into like this kind of photos, it actually can easily to spread disease because of like the different factors like birds, insects, and rodents. All right. So at the end, it will actually cause public health concerns. It will generate greenhouse gases. Mainly, we talk about the methane generation, CH4 methane generation. All right. If you are not going to collect it and reuse it, there could be a lot of other pollutants towards to the air as well, to the environment. All right. The leachate generation, which is the dirty water that you generated from the landfill itself because of the decomposition process, that will also contaminate the soil and the groundwater because of the toxicity leakage. And lastly, if you look into like this type of landfill, it actually consists of a lot of waste that I would classify as a misplaced resource. Why I say it's a misplaced resource, because if you're trying to reuse or recycle it, it actually will give you other value-added products. And because of this, it actually creates economic inefficiency, all right, because of all these precious material weightage. So again, if you look into the municipal solid waste composition, one of the composition that I would like to highlight is about food waste. So food waste is classified as an organic waste, and if you look into the structure of the composition for most of the country, food waste always consists of the highest proportion, all right. And we also know that food waste always comes with high moisture content, it's perishable, it's odorous as well. So if you are not going to treat the food waste properly, that actually will be like even a lot more concerns, a lot of issues that actually can come up. And during the biodecompositions of all these organic content, because food waste is classified as one organic content, that also will generate a methane emission. So this methane emission actually has already made like the solid waste sector as one of the top methane emitting industry. All right. So a lot of like governments or even like the countries are trying to see whether how to transfer from an open landfill to what we call as a sanitary landfill. So a sanitary landfill is actually a proper treatment managed landfill. So here just give you some idea in case you do not know how a sanitary landfill looks like. You can see that it covered with the landfill liner system. So this landfill liner, most importantly, is like to reduce all this leachate to be sipped into the groundwater, which you might contaminate the groundwater itself. You do have this leachate collection system. So this leachate collection system, you collect it, you treat it before you discharge to the environment. And most importantly, you can see there's a landfill recovery system, all right, landfill gas, all right. So this landfill gas mainly consists about 50 to 70% of this methane. You can collect it and you can reuse it either to generate heat or electricity. So here shows you one of the process flow diagram of a sanitary landfill back to Hong Kong, all right. So you can see that how Hong Kong collected all this landfill gas. They use the heat to use it on site for the leachate treatment system. And at the same time, the electricity that we're using on site as well. And somehow it will replace or avoid those electricity that you have to purchase from the fossil fuel-based power plant. So this is how you can start to avoid the greenhouse gas emissions because of all this greenhouse of the fossil fuel usage. As I mentioned, the municipal solid waste consists of different types of waste type, so it's always a complex issue. Like you have all those plastic waste, food waste, bottles, all right, electronic waste as well. So there's always no single dominating facility that you can use it in order to treat all types of waste. We have to rely on like different types of waste facility. Like for example, either we talk about a sanitary landfill, anaerobic digestions, composting, or even to work on recycling. And by having all these different types of facilities, you are also generating different valuable added products as well. So that could be like composting, you can use it for fertilizer. You could have heat and electricity, either to use it directly as an electricity or even as a fuel a biogas fuel for the vehicle use. And of course, you can have some recycled product, which you can use it to make it as an added value product, all right? And because of this, all right, we always have to think about how are we going to make sure that all these waste can be like achieved within a closed loop cycle. And this closed loop cycle we also can call it as a circular economy concept. And if you want to understand this circular economy concept, I think the first you have to understand the linear economy. At this moment, think about most of the waste that we produce or most of the products that we are using, we are following linear economy. We just take meanings that we extract all those raw material, we make the product that we would like to have it, we use it, and we just dispose it off. Of course, it's not sustainable, so we are thinking about how are we going to transfer it or translate into a circular economy. But a circular economy is more beyond than a 3R concept. It's not just about reduce, reuse, and recycle. And it's not just emphasized on the end-of-life management. We have also think about between the process itself, is there a possibility that we can reuse it or even more than reusing in order to make sure that all the waste that we generated are still back to the closed loop cycle, all right? So as I say, it's more beyond the 3R concept. And of course, there's a lot of benefits when we are able to move towards to this circular economy concept. That could be either to reduce the total cost, avoid and even reduce the greenhouse gas emissions, and of course, from the social perspective, it can enhance the willingness of acceptance. So today, I'll be just mainly focusing on these greenhouse gas emissions, all right, in terms of the waste itself. So the greenhouse gas sources and sources means that emissions, or even we can have sinks as well, meaning that you start to store with the carbon content. That could be also a very complex issue when it comes to the end-of-life management. If you look into the whole material life cycle assessment, especially if you're just focusing on the waste management, you can see that there could be a different perspective in terms of the greenhouse gas emissions and as well as the offset or the sink. Just take the example, like let's say the landfill. Just like I mentioned that if you are not collecting the landfill gas itself, there could be a release of all these methane gas emissions, all right? But at the same time, when you start to store your waste into the soil itself, from the atmospheric perspective, that could be a carbon storage from a long-term perspective. So in that case, that could be a carbon sink, right, happening into the landfill, all right? And of course, if you talk about these greenhouse gases, I think most of you are aware of this Paris Agreement goal. So under this Paris Agreement, we keep talking about how to limit our temperature to 1.5 degrees Celsius to 2 degrees Celsius as compared to the pre-industrial level. But sadly to say that according to the Climate Action Track goal, you can see that right at this moment, our Earth actually has really warmed up by 1.1 degrees Celsius. That could be really challenging if you really want to meet up with this 1.5 degrees Celsius. And also according to some scenario analysis, if you keep going on with the business as usual policies, that could be a possibility to warm up our Earth by 2.7 degrees Celsius by the end of the century. So, so a lot of things that we have to think about, it's like how to reduce the greenhouse gas emissions. And when you talk about these greenhouse gas emissions, I think we always have to look into what are those types of greenhouse gases. One of the typical greenhouse gases is carbon dioxide, and of course, it's no doubt that it's the main culprit if we talk about the anthropogenic greenhouse gas emissions. All right. But today, I would like to focus more about the methane. Methane, if you look into this pie chart, you can see that it has a smaller contributor as compared to the carbon dioxide, but it also has a much greater short-term warming impact as compared to carbon dioxide. So if we talk about a 20 years time frame, the methane actually has like 81 times more the cumulative warming potential as compared to carbon dioxide. So what does it mean? It means that if you are given the same unit mass of carbon dioxide and methane gas, 1 kilogram of CH4 will have the ability to trap the heat like 81 times more, all right, almost like 81 times more as compared to the similar unit mass of carbon dioxide. And because of this, the methane gas actually has like a very crucial role for us like to really to fight against the global warming. So again, back to 4 years, you can see that most of the governments and even the United Nations start like to really emphasize on these global methane emissions. So back to 4 years during the COP26, I think it's held in Glasgow in the UK, 105 countries have started to pledge to cut the methane emission by almost 30% by 2030 as relative to 2020. So the reasons why we want to focus on methane, as I said, it has a short lifespan. So we hope that we can have a rapid reduction in terms of to reduce the methane concentration. And with that, right, it can help to give a short-term solution to decelerate the near-term global warming. And hopefully that actually will give a short-term relief, right, for negotiation in order to cut the global emission. And again, one of the report generated from McKinsey, right, you can also see that they highlighted the solid waste sector as one of the sectors that has the most highest potential to reduce the methane emission if we are going to treat and to dispose of our waste properly. And not to mention, again, as you know that with the growing populations, with the growing GDP, all right, there will be more and more waste being generated, all right. So and with that, right, if we are not going to treat all these waste properly, there could be even more and more methane gas being generated. So with that in mind, all right, we actually think about like, is there a way or is there any study that started, to close the gap between the solid waste emission and how does it connect with all these climate goals? So we look into some of the past study. In fact, there are some of the past study that look from a global perspective to understand well how the emissions of the greenhouse gas emissions. But we found a very huge gap is that there's like no study at all that really look into these two main goals, I would say, like the Paris Agreement goals and together with the Global Methane Pledge. We found that this is important because it can actually help you to really monitor the progress in order to understand well how to reduce the greenhouse gas emission from the solid waste sector itself. And hopefully, it can also help to support the policymakers to come up with more methane mitigation strategies in order to reduce the solid waste issue. So with that in mind, we start, to also adopt a machine learning tool in order to forecast disaggregated greenhouse gas emission. So we have these two objectives. I think the first objective is that we would like to really understand well, right at this moment, based on our current municipal solid waste management practices, is that able for us to meet with the 1.5 to 2 degrees Celsius limit? So if we are not able to meet with all these climate goals, is there any like mitigation potentials that we can propose in order, in order to achieve back to all these global climate goals, let's say the Paris Agreement goals, and also together with the Global Methane Pledge? So this work actually, we come up with a very big question, is that can the global waste emissions to achieve the net zero warming futures? So together with my master's student and also my collaborators from Czech Republic and also from South Korea, we actually published this paper to really investigate how the global solid waste emissions that look like in order to achieve with these net zero warming futures. There's one news that I also would like to share with you. This paper actually has recently been awarded as the national champions for the Frontiers Planet Prize. If you know about this competition, it's the world's largest science competition that talk about the planetary health, all right? So 3 international champions will be selected in June, this upcoming June in Switzerland. So let's see who actually will go with it, all right? But here I would like to show you with a little bit of the research methodology that we adopted for this study. I try to summarize it into these 4 steps, all right? Of course, there could be a little bit more like in-depth methodology, but of course, if you talk about this study, everything will actually start from the data collection system. So we collect like all those socio-economic data, hopefully to understand well what would be the correlation that look into how does it affect the municipal solid waste generation. We work on 43 highest municipal solid waste generating countries and regions that actually cover almost 86% of the global municipal solid waste. We started to calculate with all these greenhouse gas emission from a bottom-up approach. A bottom-up approach means that we really look into each and every individual country. We look into all those government reports, understand well the trend, the way, how they really collect the waste, and what types of the municipal solid waste composition as well, and how they dispose and even to treat the waste. And we use these IPCC guidelines to really calculate for all these greenhouse gas emissions. Most of the countries or even the regions that can even able to achieve with a tier 3 approach, meaning that we are able to use all these specific data that tailor-made or specifically tailored to all these countries. But of course, if you talk about some of the underdeveloped country, because of the lack of data issue, we have actually used some default value as suggested by the IPCC. All right, but we of course acknowledge that there could be some limitations of our study. So in that paper, we also call for the policymakers or even the governments to make more transparency in terms of the data sharing. The second step is about forecasting the municipal solid waste generation. So for this, we use a panel data regression model, always looking into the projected populations and the GDP per capita based on the shared socio-economic pathway, SSP. So this SSP, it's actually just talk about like what would be the future scenarios in order to understand the world's ability to really mitigate and to adapt the climate change challenges. It consists of 5 SSP, but we always look into the SSP2 because that's the most practical, I would say, based on the current business as usual policies that we are developing. And for step number 3, this is how we start to adopt with the Bayesian-optimized artificial neural network model that we developed back to our past paper. And for this one, why we use this Bayesian-optimized? Because it could help to optimize the hyperparameters methods, which will help to reduce or minimize the root mean square error. All right. So here we do the forecasting, looking into the greenhouse gas emission from the 2021 to 2050, based on the historical data that could be way back up until 1990s, up until 2000, and some even up until 2020, some just up until 2010. All right. And the last part is that after we do all this forecasting analysis, we also started to create some scenario analysis. The idea why we want to create this scenario analysis is to understand well the emission budget to achieve with this 1.5 to 2 degrees Celsius. So the emission budget is actually kind of what we call as an amount of the greenhouse gases that you are allowed to emit in order to make with the 1.5 to 2 degrees Celsius. So we start to factor just like back to the global municipal solid waste system, which is to talk about almost 2% of the total greenhouse gas emissions. And we look into what we call as the transient or climate response to cumulative carbon dioxide emissions. We acknowledge the uncertainty, so we look into the 50 percentile and also the 67 percentile, all right, in order to work out for the 1.5 to 2 degrees Celsius level. So here shows you some of the result and discussion, all right. I think the first question, as I said, is like, based on the current municipal solid waste, is that a possibility to make with the 1.5 to 2 degrees Celsius? Yeah, sadly to know that based on the current municipal solid waste system, it will definitely exceed the 1.5 degrees Celsius. What we actually think about is like 3 years from now. We are talking about 2028 to 2029. And if you talk about 2 degrees Celsius emissions budget, that could be up until like 2038 and 2043, all right? So here we know that something has to be done on this global municipal solid waste management. So we try, to like come up with a few mitigation potentials, and just focusing on the SSP2, as I say, this is the highest likelihood given the current policies that we are looking into. So we come up with these 4 mitigation strategies. The first one is half waste. This half waste actually aligns to the SDG 12 goals as well, the sustainable consumption and production, in which we are trying to halve our waste by 50% by 2030. All right. And secondly, we look into digesting the organics, which is what we call anaerobic digestions. We also start to work on the composting organic, all right? And lastly, to retrofit the landfill, meaning it's like changing the landfill from open landfill to sanitary landfill. So we found that for all these individual mitigation strategies, they do have some effectiveness, ranging from 33% to 73% in order to reduce the greenhouse gas emissions, all right? But we also found a very interesting part. The finding is that the effectiveness of the mitigation scenarios could be varied according to the income levels of the country. So let's say if you focus on the high income country, you can see that halving the waste generation is the more effective. But if you look into all these like lower middle income country, somehow diverting the organic waste to the biological treatment can be more effective. It's not about the halving waste. Mainly because for all these countries, most of them actually they have a higher share in terms of the organic waste. So here comes to a conclusions, all right, findings that we like to tell the policymakers is that there's always no one-size-fits-all solution to treat like this waste type. You have to really like always look into the local conditions, the local environment, to understand well what would be the types of the municipal solid waste, the composition. Only then you will be able to identify what would be the best solution for them, all right? And you can also see that the greenhouse gas emissions potentials can be always integrated to link to the different income levels of them. And of course, you do have all these mitigation potentials. We also start to understand well, how does it able to meet with the 1.5 degrees Celsius? So if you look into the retrofit landfill, so these are two lines, shows you the retrofit landfills, all right? Somehow, if we try to like work out for retrofitting all these open landfill to sanitary landfill, it's still marginally to stay within the 2 degrees Celsius, but it's not able to achieve the 1.5 degrees Celsius at all. And if you look into the other individual mitigation potentials, like for example, composting or even half waste, yes, it's pretty possible to meet with the 2 degrees Celsius, but again, it does not able to meet with the 1.5 degrees Celsius. So what actually we would like to propose is like, how about we try to do a combination? Meaning like we try to combine all these three strategies, the retrofit, landfill, composting, and half waste, and to come up with these all strategies. And for these all strategies, somehow we found that adopting all these three strategies, it allowed a one-off carbon dioxide emission, which allowed us to achieve this net zero warming. So here we come out with a key conclusion is that the integrated waste treatment facilities is always important when we start, to treat different types of waste. Again, as I mentioned, that there's no one-size-fits-all solution. You cannot just rely on one single dominating facility to treat all these type of waste. So here shows you like how the importance of having an integrated waste treatment facility to be implemented in the country or in the region. And the second, let's talk about the Paris Agreement goal, and how about the Global Methane Pledge? So if you still recall, we talked about 30% of the CH4 reduction by 2030 as relative to the 2020. So by combining with all this complete adoption of the mitigation strategies, yes, we're able to reduce up until 80% by the year of 2050. But you have to think about like this 30% reduction, we are talking about the year of 2030. So if you want to really achieve this Global Methane Pledge, we found that at this moment we cannot handily reduce it. So you have to really accelerate the complete adoption by at least 9 to 17 years. All right. Only then you are able to meet with this Global Methane Pledge. So if you look into all these proposed mitigation strategies, retrofit, landfill, composting, half waste, we are not talking about all those like advanced or very high technologies treatment system. It's actually some of this waste treatment system has already been widely adopted in some of the countries. But it's a matter that how fast that we actually have to adopt for this technology. So we come up with a key conclusion saying that the existing technology actually are always there. So if you want to really meet with this Paris Agreement goal, the Global Methane Pledge, you have to really act fast because it's not saying that you try to like work out for the retrofit landfill by today and tomorrow you will see a very significant carbon dioxide or even methane gas reduction. It actually takes time to manifest. All right. So this is how actually we propose in this study. So what would be the next step? All right. For this study, we provide an evidence-based approach, or what we also call as a data-driven approach, in order to understand well how the global municipal solid waste emission to link with the policy. But of course, if you talk about like implementation, it still relies on the policymaker itself. All right. So we think about like how to translate our data or even our future policy action to make it easier or even like facilitate the communication together with the policymakers. So we think about like how to integrate with the AI-based data-driven analysis to produce all these policy tools. Like for example, we can think about the blockchain technology or even the large language model in order to facilitate the policymakers to identify what would be the best way, all right, to reduce the greenhouse gas emission in the solid waste emission. And all this policy has to be integrated with all these three perspectives to talk about the regulations, the economic, and even the social perspective. So to make it like more realistic, we also think about like all those implementations of this incentive. It also has to be like really tailor-made to each and every country's social economic context. And after all, we also think about like fostering awareness is still the most important, all right, area that we have to really look into. Because if you really want the people, even the governments to work on that, capturing the attention and fostering the awareness is still a very crucial step. So we think about like how to encourage the governments, all right at this moment to really collaborate with the business enterprise and even the individuals in order to implement all those mitigation strategies. And lastly, we hope that when the government or the business enterprise are doing something, the model applications can be easily to extend to the individual as well, and to encourage them to alter their consumption and even their disposal patterns. All right. So that's all about the sharing. All right, for this study, I think I still have a little bit of time. I also would like to share with you some of my other publications that relate to this solid waste emission. As I say that my research are mainly focusing on the interplay between the environmental, economic, and together with the social perspective. So I always think about like, is there a very good way that we can easily to translate our result and to inform the policymakers so that they can easily to bridge the connection between research and together with the application. So this is one of the study that we developed a relative quadrant eco-efficiency just to integrate the economic and together with the environment. But you can see how we start, to link the result into like kind of an eco-efficiency quadrant. Hopefully that they can easily to compare with the different scenarios over there. All right. So you can see that this is the business as usual case. So whatever like quadrant that you fall, you can easily to know whether this is more economically efficient or it could be like non-eco-efficient at all. We also started to link the life cycle assessment together with the multi-objective optimization because we know the limitations of LCA is that they can help you to evaluate the environmental impacts, but they could not give you optimum solution at all. All right. So this is how we start to integrate LCA together with MOO. And we also look into different perspectives like human health, environment, together with the economic as well. And for this study, we try to integrate with the social perspective, what we call the 3P, the planet, prosperity, together with the people. All right. So here we work out with the social life cycle assessment, utilizing the Bayesian-optimized method to get out with a social score. And again, we develop this 3D sustainability portfolio to easily to translate our result. So we have a visual perspective on understanding the relative comparison on that. We also think about like how to consider the externality in terms of the solid waste management. So if you understand externality, we talk about all those environmental impacts. So if you look into like, for those who are working on LCA, you can see we not just always focusing on global warming, we can also focusing on the other impact category as well. But if you look into all these units, if you talk to the policymakers, they have no idea at all. They do not know what does it mean as like kilogram PM 2.5 equivalent. So we think about how to translate our result into an external price and integrate together with the budget cost, which we also try to work out for optimization road. And for this study, we're just focusing on the plastic waste management. And we also make this study utilizing Malaysia as a case study. All right. So here, we easily to come up with the ideas, the solution, the optimum solutions on how to reduce the plastic waste management in Malaysia. But of course, there's still one more limitations when you talk about the externality cost is that you have no idea what would be the best location, all right, to build out or to come out with your recycling plant or even the location, all right. So this study actually we worked together with Prof. Yu, all right. So this is the Malaysian map. We talk about the peninsular Malaysia. You can see how we understand now the dynamic change in terms of the location perspective, ranging from the business as usual case, which is happened in the year of 2022 and up until 2050. And if you know well how we should locate our waste treatment facilities, all right, within these all areas. Okay. Yeah, all right, so I think that's pretty much about my sharing. So I would like to make a few key takeaways, all right, for my talk today. I think the first idea, we keep talking about the waste circularity, all right. No matter how waste circularity is still a very important concept in terms of the municipal solid waste management. You can see that I still use the word concept, all right, because if you talk about the adoption of this waste circularity, it's still not widely adopted. It's not saying that it's not able to implement. If you talk about some of the case study happening in some of, let's say, a city or even a company, the waste circularity concept actually has already been started to be adopted. But of course, it will still be very challenging if you want to work it out from a nation perspective or even from a global perspective. But it doesn't mean that it could not be worked on. And secondly, you can see that my study, as I say, I'm always utilizing all these sustainable process and system analytical approaches to do a lot of predictive analysis. Some people might say that why you just keep doing all this prediction, which might not be happening, all right, in the future. But I would like to quote from Professor John Stigman from MIT. He stated that simulation let us imagine a better world and discover how we can make it real. My study, I always use all this evidence-based approach, or we call it as a data backup study, in order to provide more data-driven or informed decision makings to the policymakers. So hopefully that they can be more effective in terms of working on all this policy making. As I mentioned, the waste always has to be a very complex issue. So an integrated waste facility is always important. We cannot just always emphasize on one single solutions in order to treat all different types of waste. And lastly, always remember that waste is just a misplaced resource. It's actually not considered as a waste if you try, to give it a second life on that. All right. So always think about if you start to throw it away, are you throwing to the right way or the right place? All right. So I think that's all my presentations. I would like to acknowledge my students. This is back to Xiamen University, Malaysia, all right, my team over there, and some of my collaborators, all right, and some of the fundings of the grant funder, and the industry partner that also provide a very good data, all right, to all of us. And yeah, I think that's all for my presentation, all right. So if you have any question, feel free to drop me an email, or of course, I think we still have some time. We can have some Q&A. Yeah, I think that's all. Thank you.
Thank you very much. Wonderful. Yeah, we have people raising hands. Please, go ahead.
Yes.
Presentation. I'm just curious about how did you rerun the whole simulation based on new policies or scenarios of waste management system? I could see that you could take SSP2 and say, if we have new implementation, it will happen. I just wanted to ask, is there any dynamic relationship between when we change the waste system, management system, that it does change other dynamics too? So you'll have some kind of feedback loop on the overall total greenhouse gases predictions. My question here is that, did you consider these loops back and forth, or how did you set that threshold that just specified to waste?
All right. Okay. As I mentioned that for our study, we actually divided into these two phases. The first phase is that we try to understand well first the current scenario. How does it happen? The current scenario. So the current scenarios always we talk about like the current existing facilities. So all this is like back to the historical data. All right. We understand well, like for each and every country, what are the typical ways that they treat and even dispose of their waste, and we also understand what would be the waste composition. And from there on, we calculated with all these greenhouse gas emissions. All right. So over here, we start, to compare with the emission budget that we talked about, which mainly on 1.5 degrees Celsius and 2 degrees Celsius. All right. And that's the first phase of our study, which you can see how it connects to the results that we are not able to achieve it. And here we started, to come out with some mitigation potentials, all right? So those mitigation potentials, we talk about like what actually could be happening in the future, all right? So when we talk about like the adoption on all these waste facilities, let's say retrofit landfill, all right? Some of the countries already adopted like the sanitary landfill, but of course they are not like up until 100% on that. So we think about like if we really want to adopt this retrofit landfill into that particular country up until the year of 2050. We make 2050 as like the limit on that. So we kind of like looking into a linear adoption in terms of like how they are trying to increasing, all right, the adoption of this retrofit landfill. So once again, we deal with all these greenhouse gas emission calculation on that. And with that, right, this is what we call like the mitigation potentials. All right, understand well how like with all these like new adoptions, whether you're able to achieve with 1.5 or even 2 degrees Celsius.
Just one follow-up question about the threshold that you set for 1.5 degrees Celsius. Is that greenhouse gas emission? Is that just for total global emission or just for waste?
Just for the municipal solid waste, all right, yeah. Otherwise, it doesn't make sense, all right, like how to make out with the 1.5 to 2 degrees Celsius. Previously, we also received some very good questions like that keep asking me why you want to emphasize on solid waste, because when you talk about the total global waste management, the total global greenhouse gas emissions, energy, building, transport, that could be even more like significant on that, all right. But as I mentioned for our study, we actually want to like come out with another perspective, which is the methane emission, all right? And we know that methane emission actually will gain like more and more traction, mainly because the short lifespan, which will give us like more time, all right, to have a rapid reduction on that. But it doesn't mean that we're still able to achieve the climate change goal from a major perspective on that. Yeah.
Thank you so much.
Yes.
Sure. Thank you for your presentation. Considering the time zone differences, I'm still surprised that it's still like really active in the presentation.
All right. Thank you.
I'm actually curious because like you mentioned that there's a significant impact of still having a lot of methane compared to like carbon. Why is there no there is a carbon market. Why is there no methane market there? Or what's the difficulties?
Actually, if you talk about carbon market, they also look into carbon dioxide equivalent, all right? Not necessary to just focusing on carbon dioxide. If you talk about like energy sector, all right, when you work out for the emission factors, they are like always looking into the carbon dioxide equivalent, all right? So in another word, they also factor into the methane emission. But of course, when you look into this energy sector, almost like 80% are still coming from, when you burn with your fossil fuel, mostly are still the carbon dioxide, not the methane gas. So that's the reasons we also like still using the word like carbon markets.
So is that the solution for the incentive part, or is there like another solution that you're thinking about in terms of like?
Well, carbon markets is one of our potential, I would say that a potential incentive that we are looking at. If you look into the economic incentive, there could be a lot of ways to work on that. Not just only carbon markets, carbon tax also can be a very effective policy, especially for countries that do not have a complex or a regulated carbon, a market-based carbon market. All right. So with that, right, carbon tax actually can be implemented even faster. If you talk about Malaysia, carbon tax actually will be our priority. It's not about the carbon market. Of course, we do have this carbon market, but it's a voluntary basis. We're still following a VCM, not like having a proper carbon market right at this moment.
questions?
Yes.
Yeah, thanks for sharing. We see lots of insight about socioeconomic scenarios, but I'm interested in how did you connect the SSP to your results? Explaining about the population, GDP, or we consider the development of different treatment technologies in the next maybe 20 to 30 years? Yeah.
All right. Well, as I said, before we work on the data panel, data regression, we want to understand well the correlations of the municipal solid waste generation together with the socioeconomic indicator. And when you talk about socioeconomic indicator, there could be a lot, all right, from the populations to GDP to even if you talk about education level, there could be socioeconomic indicator as well. So we work out with Persian correlation, all right, we understand well that what would be the highest correlation factor that easily to correlate to the municipal solid waste generation rate. And a lot of study, all right, that actually has been worked out, and also it's aligned to our findings. Populations and GDP are always like the two key important, all right, indicator that we always have to emphasize on, all right. So with that, right, this is how we start to link with the SSP, because SSP actually is a forecast with the populations and the GDP as well. So we also try like to understand well in the future, all right, how this GDP and population growing, and with that actually will use the data pattern regression to link it back to the municipal solid waste generation.
I have some other questions, or we can talk later. Maybe.
Sure. All right.
So since we're close to time, please again join me to thank Professor WOON again for a wonderful presentation. And
Thank you.
if anyone has follow-up questions, please feel free to talk to him. He's going to